Okay, this is the part 2 to 8.2. We're talking about arithmetic sequences. And we're going to use more of that formula that we learned in 8.2 part 1. So we're going to now write the rule, so that's what we need that formula for, but we're given different things. We're not given the first term and the difference every time. We're given one or the other, or just two random terms in the sequence. So it's important to remember the formula for arithmetic sequence, and that was AN equals the first term, which is A1, plus N minus 1 times D. Okay? And then sometimes, like I said before, you can rearrange that last bit and say A1 plus D times N minus 1. Okay? Now, for number 1 here, this gives us a term in the sequence, and it gives us the common difference. So to write our rule, we are wanting A1, okay? Now this A11, that's going to tell me that I'm wanting term number 11, so that means N is 11. AN will equal what that equals, which is 50, and we know that D is 7. So we're going to use that information to step 1, find the first term of the sequence. Okay, so we're going to find A1, which is A1. Okay, so I'm going to plug it into the formula. AN, I'm going to write the formula out first, equals A1 plus D times N minus 1. AN we said was 50. We do not know A1, so I'm leaving it there. We know D is 7, and we know N is 11. All right, now if I simplify this, 11 minus 1 is 10, times 7 is 70. Okay, and then we solve for A1. So I subtract the 70 to both sides, and I get A1 is a negative 20. Okay, so that's part 1. Okay, step 2 is now write the general rule. Okay, so that's what we're going to use this equation up here for, or this one or the other. They're the exact same. Just D is either before or after the N minus 1. But we're going to write that general rule for any term in the sequence. All right, so we go back. We ignore now that we have this first term. Okay, we're going to do what we did in part 1. We know our A1 and we know our D. And we're going to use those and only those to find the term for any, or the equation for any term in the sequence. So AN is going to equal A1 plus D times N minus 1. We distribute the D, the 7. So I get negative 20 plus 7N minus 7. I combine like terms, and I get 7N minus 27. Okay, so that is the rule. And then the third step, it wants us to, whoops, I guess that should have been blue. Funny. All right, it wants us to find the next 6 terms in the sequence, okay? So we're going to use the rule. That's what we just wrote, to make a table or to find your first 6 terms, however you want to look at it. I make the table because to me it's easier to keep things separate. Well, I want the first 6 terms, so N is going to be 1, 2, 3, 4, 5, and 6. And I'm going to plug in N into that equation. So to find the first term, I'm going to have 7 times 1 minus 27. Okay, and I get negative 20. Okay, so this is the first term. Okay, plug in 2. 7 times 2 minus 27 is negative 13. 7 times 3 minus 27 is negative 6. 7 times 4 minus 27 is 1. 7 times 5 minus 27 is 8. And 7 times 6 minus 27 is 15. So you would write these terms out with a comma in between each of them. Okay, so that's what it wanted. We wanted to write the rule for the nth term, and that was this, and then list the first 6 terms in the sequence. And it gives us, this just told us it gave us a term, a random term. In this case, it was the 11th term, and the common difference. Now, if you want to check to make sure this rule works, it gave us term 11. So I can take and I'm going to plug in 11 for n, so 7 times 11 minus 27. I better get what it told me it should be, and you do. You get 50. Okay? All right, let's try it again on the next one. Okay. Step 1 is finding the first term. So n is 12. Oh, I'm writing 12. That's the n, because it's a, and then the sub number is always what n is. This then would be an, and this is d. And we plug it into our standard equation up here. So I'm going to have an, instead of writing an, I'm going to, an is 52. Sorry, I just said right here what an is. Equals a1, which is what we do not know, equals d, not equals, I'm sorry, plus d times n minus 1, and n is 12. Okay, 12 minus 1 is 11, times 6 is 66. We subtract 66 from both sides, and we get that a1 is going to equal negative 14. So that was step 1, was find the first term. To write the general rule, you need a1, and we need d. So an is going to equal that first term, which is negative 14, plus d times n minus 1. Distribute that 6, negative 14 plus 6n minus 6, and collect like terms, so I get 6n minus 20. All right, and at this point, if you wanted to check to make sure that works, you could plug in 12 for n and make sure you get 52. And you do in this case. So step 3 wanted us to find, or the second part of this problem wanted us to find the next 6 terms. So I make my table. 1, 2, 3, 4, 5, 6. And if I plug in 1 for n, I get 6 times 1 minus 20 is negative 14, which we said right here should have been our first term, so that should be correct. 6 times 2 minus 20. 6 times 3 minus 20, 6 times 4 minus 20, 6 times 5 minus 20, and 6 times 6 minus 20. So this is my sequence of the first 6 terms. You would, when you type them out or write them out, you would separate them by a comma, okay, and just list the numbers. All right, in number 3 and 4, I have all these little marks here. Let's see. It is now giving us just 2 terms. Now I don't know d, I don't know the first term, and I need to find those things so that I can write my general rule. Okay? So for the first step, we are going to write a system of equations using the 2 terms that were given, okay? And we're going to do this, and we're going to find d, okay? We're going to find our difference. So this one right here tells me n is 7 and an is 71. So if I write that out using the equations that we know, we get the equation 71 is going to equal a1 plus, and now this is where I want the n minus 1 here, and d. Okay, n is 7. We don't know d and we don't know a1. Okay, this can simplify to 71 equals a1 plus 6d. Okay, and let's do it for the second equation. This is telling me n is 16 and an is 26. So I don't know a1, but I know I have 16 minus 1 and I don't know d. So that simplifies to 26 equals a1 plus 15d. Okay, this is a system of equations. Now, to solve for D, I'm going to take one of these equations, so this one, and I'm going to subtract it from the other one. Okay, so I have 71 minus 26 is 45. A1 minus A1 is 0, so they cancel. And then I have 6 minus 15D is a negative 9D. To solve for D, we divide by negative 9 to both sides, and I end up getting D as negative 5. All right, so now I have my first term, now I have my difference. To be able to write the rule, we also need the first term, which we can do this by substituting in. So the second step is find, that's a D, A1 with substitution. That's a long word, doesn't fit. Okay, that's a substitution over there. Here, move it over. Substitution, there we go. So I'm going to take D, and I'm just going to plug it into one of these original equations here. And so I end up getting 71 equals A1 plus 6 times negative 5. Okay. Then I get 71 equals A1 minus 30. Add 30 to both sides, and I get A1 is 101. So now I have A1, and I have D, and now we write the general rule. Okay, so it's AN equals the first term, which is A1, plus D, which is negative 5 times N minus 1. We need to distribute the negative 5, so I get negative 5N plus 5. Collect like terms, so I have negative 5N plus 106. There's our rule to find any term in the sequence. And you can double check it by plugging in 7 for N, and so you take negative 5 times 7, add 106, and you should get 71. And do the same thing for 16, and it should work out. Now, if it asks you to find the rule and the first 6 terms, well, you do what we did up above here and plug in 1, 2, 3, 4, 5, 6 and get those 6 terms and list them. All right, so number 4 here, let's separate that out here. It gives us the 2 terms, so we need to write our system. This says N is 5, AN is negative 43. So negative 43 equals A1 plus 5 minus 1D. I'm going to erase that just so I can write a little smaller here. I get negative 43 equals A1 plus 5 minus 1D. Okay, I wanted to be able to put that equals a negative 43 equals A1 plus 4D. The next one is when N is 12, AN is negative 8. So negative 8 equals A1 plus 12 minus 1D. And that turns out to be negative 8 equals A1 plus 11D. All right. Now this is where we take these that we simplified out, and I'm going to subtract the bottom one from the top one. So I have negative 43 minus negative 8. So that really is negative 43 plus 8, and that gets me negative 35. A1 minus A1 is 0, so those go away, and I have 4 minus 11 is negative 7D. Then I divide by negative 7, and I'm going to get D as a positive 5. Okay, so that was step 1. We found D. Step 2, we find A by substituting that into one of the original equations. And it doesn't matter which one, so this time we can substitute it into the negative 8 equals A1 plus 11 times D. So that's negative 8 equals A1 plus 55. And we subtract 55 from both sides. A1 is going to equal a negative 63. So I have A1 and I have D, and now I can write the general rule. So AN is going to equal that first term plus D times N minus 1. Distribute negative 63 plus 5N minus 5 and collect like terms. which would be 5n minus 68. And you can double check that when n is 5, you get negative 43, and when n is 12, you get negative 8. And then that should tell you your answer is correct. All right, so now down below, instead of just giving you a term and a difference or two random terms in the sequence, now it's going to give you a sequence in a picture, or it'll give you a sequence as a table, okay? And we treat the table almost the same way we're going to treat when it gave you just two terms, but there's a little trick when it's close enough to the first term. So let's look at the graph first. When n is 1, or when x is 1, that y is our first term. So I know that a1 is going to equal negative 4. And we need our d. Those are the two things we always need to write the general rule. Well, d is when it goes over to the next term, which in this case it goes from 1 to 2. How high up did it go? So what's our rise here? Well, it went from negative 4 to negative 3, so it looks to me like it added 3. So d is going to be a 3. And I plug that into the equation. an equals the first term plus d times n minus 1. And I distribute. And I collect like terms. There's my general rule. And you can plug this in, like find one of these other ones that we didn't do. Okay, well, when n is 4, I get 3 times 4, which is 12 minus 7, and I do get that 5. So that did work. Ooh, I don't know why I was erasing that, sorry. And that did work with our rule that we came up with. All right, number 2 here gives us, starts with term 4 in the sequence and gives us what those terms are. So, what is that? Sorry, technical problems there. But if we continue this on, if we go backwards, if I say, okay, term 3, term 2, term 1, I can easily find the first term without having to manipulate and plug in and find a system. But it looks here like I'm adding 4 each time. So that tells me that's what d is, okay? So I know d is 4. Well, if I'm adding 4 each time to move to the right, subtract 4 each time to move to the left, so I get 21, I get 17, and I get 13. So that means A1 is 13, okay? Now that's a way to do it without having to do the systems up here, like we did on 3 and 4. But you have to find D first, and without seeing every term, it's hard. You have to do step 3 and 4 like that system to find D. In this case, we know every step, so we could find D by looking at what is it doing to get to the next term. So now I can write my rule. AN is the first term plus D times n minus 1. So AN is 13 plus 4n minus 4. So AN is 4n plus 9. And then you can double check it by plugging in a random number like 7. 4 times 7 plus 9 is 37. So that is the notes for 8.2 part 2.